All right, welcome to another episode of the Bioinformatics Lab podcast. I'm Kevin Libwit with Andrew Page. We're from Theogen, and today we're talking bioinformatics in the cloud. Not a super new topic at this point. We've been adopting cloud over the past 5 or 6 years, but it's still something to a lot of people that is a big jump for their infrastructure. There's a lot of bioinformatics scientists who, for example, maybe their institution went the route of investing in an HPC and they've been stuck in an HPC, but finally their ITs maybe realizing the limits of maintaining that and even the compute hardware that they have. And so they're looking into the conversation of going into the cloud. So you and I both have a ton of experience in this. Did you have that experience actually of the migration from like an HPC system into a cloud system where you had to make those
Yes.
considerations in your lab?
So we were on like your classic physics cluster where giant blades and a room full of
Nice.
computers and that kind of stuff. And so when I left Quadrum, that's exactly what we're doing. We're at that, we're probably 2 years into transition from maybe 3 years from that kind of traditional HPC into the cloud, and we had an open stack, so a private cloud on site. So it's not, like when we talk about cloud, we would probably talk about public cloud like Amazon or Google or Azure. But that, if you move into any of those clouds, it's as easy to do one as it is to do the other. It's breaking that link from having a computer under your desk, high-powered server under your desk or in a room beside you, and moving into something a bit more modern and where you can utilize the resources in a very different way. Like you can overcommit, say, CPUs, so you can get a lot more out of the resources you have, because often you'll run a job on a traditional HPC and you ask for resources, but you don't necessarily need them, or maybe you're using half the resources you required at a particular point in time because you're waiting for some IO or downloading something. And the ability to be able to actually make full use of those physical resources by overloading something and swapping something in and out actually is quite useful. So yeah, I've seen that transition. It's hard because you need to do fundamentally different things. It's different software, different everything, but it works.
But was there a lot of buy-in from the get-go from your IT of like, all right, we're going to make the cloud jump? Because I think what we see a lot in public health is a ton of resistance of, hey, that is really new to us. We know we have sysadmins who know how to, administer the security and robustness of our on-prem services. What the heck is cloud, and why are you asking me to move everything up there? Did you guys experience that same friction point?
There was, but initially, but actually, because it was on-prem cloud, it meant
Mm,
that the same people were the ones running it. So it wasn't like any staff were being lost or anything like that. It was just there was a different way of working, and it gave us more freedom as well. And obviously, there's complexities with these things, and changing firewalls and all that kind of stuff. But
yeah,
actually, it worked out pretty well because it moved a lot of administration from, say, the core IT to the research groups, to the core research groups, which meant that we had more control. We could have root on VMs, things like that. But it was done on the assumption that if something went wrong, it was your problem, not kind of the core IT's problem, which,
yeah,
was actually fine. And we got buy-in simply because I didn't buy as much resources as people needed. On the old HPC, I bought a teeny tiny bit, and
yeah,
then it was like a huge amount on the cloud. So if you needed resources, you had to use OpenStack, you had to use the cloud,
yeah.
which was very good for encouraging people. But also what we did was we installed Galaxy,
Mm.
which is like a workflow manager, kind of point and click. And so that allowed people to, they didn't care where they ran this stuff. It would just be Galaxy was running it for them through a website, and they point and click to upload some samples. Or we're using Irida actually for
Yeah.
doing data management of samples. So samples would come from the sequencers into Irida, which would store the raw data, and then they'd click, I don't know, add stuff to the shopping cart. I would run some analysis, so go into Galaxy, and then they could run some pipelines. Different to Terra. It's more aimed at, I guess, the researchers who want to be able to, fiddle with everything, and drag and drop workflows and that kind of stuff. But it gets people there in the end, and that was the motivator. And they didn't care where stuff ran as long as it ran.
But in really similar concept to Terra in that it provides some end users a graphic user interface with an access to both the workflows and then, like you said, this cloud compute backend that was, inherently scalable.
Yeah. And then I guess one of the big things about the cloud is, right, if you have to buy stuff in a university, it can take a long time. You ask for money, it might take 6 months to get the money through the door. Then you ask for to go and buy stuff at that point, and then that's maybe another 6 or 12 months, by the time it goes through procurement, because these are, big bags of money. So you have to go out to tender, you have to, go through all these processes, you have to get stuff delivered on the site on trucks. Someone has to physically come in and connect up wires. Then you have to do the software setup and installs, and that just takes a long time. So, the actual end to end can be 1.5, 2 years from when you decide, yes, I want to do something to, or I need resources, to actually having it there ready to go.
Yeah, and
Whereas cloud is
added,
different.
an added point of complexity to that is you have this maybe bolus of funding in front of you, and you're kind of asked to predict the future a little bit of how much is the maximum compute you'll need for maybe the next 5 or 10 years or something like that.
Yeah.
And it's just like, okay, let's just go as big as I possibly can. And what we've seen too over the past couple of years is the sequencing volume's gone only up in the number of samples and specimen people are analyzing. So I don't know that many people would have been able to budget or allocate like these are the number of resources I need. I know I'm going to need for the next 5 or 10 years, because
Yeah.
once you put that HPC system, you are like limited by the physical constraints of what you've bought, and that becomes an issue.
Well, that's what I had to do on a number of occasions, is estimate what we need in 5 years' time. So you buy stuff now today for what you expect to need in 5 years' time, which
Mm-hmm.
is insane, because everything is more expensive, and or is cheaper in 5 years' time. It's slower, it's whatever. So you got to do this kind of look into your crystal ball and go, yeah, we'll probably double the amount of storage we need every year,
Yeah.
and then you buy it now at a more expensive price, rather than just buying it as you go along. You can't do that. And it's just kind of crazy what to do. Whereas compared to the cloud, you just literally take your credit card out and you have it now. You don't wait. It's just you click a button and there you have it.
Yes. So there's a lot less friction to get it. And then you have at your disposal all these different resources as you need it. Obviously, dependent on the way in which you structure your system and your workflows and being able to scale and things. But that becomes, I think, for a lot of IT departments that are looking to support this, that becomes okay. That's the blessing to the laboratorian and the bioinformatics scientist, but that's the huge concern for the IT, because that means they can scale this at will, right? And so you are trusting that their will is, guarded by good software development practices, and they are putting some level of caps that may not be enforced otherwise, right? Because you could have a runaway job that could just spin things up. And if you're not monitoring, this is something you and I have had to do recently, make sure that we have proper cost dashboards so we can see instances of spikes. Because yeah, as things grows, your user bases grow and things like that, egress fees might sneak up on you and
Yeah.
cause occasional spikes. I speak from personal experience.
Like I've seen, in academic settings where like a PhD student will go and launch 100,000 jobs accidentally,
Yeah.
and it brings down the entire cluster and whatever. But at least it's internal, and someone can go, that's a bit silly, kill, and
Yeah.
it's gone. Whereas in the cloud, you might go a day or two or three before people actually notice, and you've gone and spent vast sums of money,
Yeah.
because the resources can be limitless depending on how you do it. And so you do have to be careful, it is one of those
Yeah.
pitfalls.
It goes from that was silly, kill, all right, you've learned your lesson, to now that was silly, kill, we owe $10,000. And it's like, oh, that's our budget for the
Yeah.
conversation.
But also there's things you can do to reduce costs on the cloud.
Yes.
It's very good because you don't have to capital expenditure, you don't have to hire people to run
Yeah.
stuff, and you get the economies of scale from, if Amazon or Google buy computers, they're not paying, the price in the local store. They're paying like rock bottom,
Hmm.
tiny, tiny prices, and they've optimized them down to a T. Um, and yeah, so you can make use of a lot of you can optimize a lot of the costs. So things like spot pricing, as an example,
Yeah.
that's where you say you have a short running job, and if someone else needs resources, you're fine with being killed. which is totally fine for some things. It's not fine for other things. But, if you just need to, have things spin up and down, you don't really care. You might be doing minor little things, or maybe it's progressive, it's progressively doing some analysis. Spot pricing can be great because it's about 90% cheaper than
Yeah.
kind of your dedicated resources, which is great. You can just slot in and out wherever you need to.
Yeah, and knowing those little tips and tricks on how to do spot pricing, ensuring like your compute environment is reasonable to the task. So I'm speaking more so to the people who are using things like Nextflow or Whittle, where per analytical module you get to define your compute environment. You can even be a little bit more dynamic in that too, if you get a bit sophisticated based on like with the data input. This is generally how much I'm going to need for memory or for RAM or storage even. So yeah, you can continuously optimize. So that is the undeniable benefit of cloud. And I think across the field, we're really seeing the wide adoption. It's happening. So again, if we're speaking to maybe some of the listeners who are a little bit early career in their route to bioinformatics, this is a skill you got to learn. And maybe one question people are going to ask of like, which cloud provider is the one to jump into first? Is it AWS? Is it Azure? Is it what am I missing? GCP? Do you have a perspective on this? I've gotten a chance to dabble in all three of these, but curious where your head's at on that.
Yeah, so I've used AWS, GCP, and OpenStack,
Mhm.
and to be honest, they all have quite similar things that they provide, and for the most part, if you're doing straightforward kind of informatics, you probably don't care about 99% of the features that are provided. Often, you might just want to run some jobs. You need a VM of a particular Docker image or whatever to run some analysis and get the results back. That's it seems straightforward, and it usually is. And you have higher level things like say Nextflow can actually, it doesn't matter, what cloud is underneath or infrastructure is underneath, it'll, choose the right one, and it'll do that kind of translation for you, use the right resources. And so for most people, it doesn't really matter. It's just the big jump is actually using the cloud in the first place versus not using it. And
Yeah.
then designing software using tools that allow you to use it effectively, like say Nextflow or Terra or whatever, or Galaxy. So it's that mental leap from, yeah.
I'd agree completely. I think for a lot of the bioinformatics side, if you're doing the bioinformatics development and software component of it, there all the tools that you'll need in AWS. There is an analogous resource in Azure and GCP and all the other ones. And that those are probably those things like you have a VM, you have an ability to create a VM, and then something maybe that will give you some level of a server mode capability where you can in batch, as an example, where you can from a VM submit a job that says, hey, I'm going to need this amount of resources for this analytical process, et cetera. And a lot of that is already sort of abstracted away whenever you're using like Whittle or Nextflow. So long as you get things configured, that's probably the hardest part in learning, what do they call a VM here? What's a blob versus a bucket versus a whatever storage system in across the different resources. But at that level, you're going to be interacting with the same kinds of systems, be it EC2 instance or a GCP instance or an Azure VM or whatever it is there.
Yeah, and it's kind of cool, but there is some pitfalls as well, like that you don't have on a local system. Like, oh, one time I spent a fortune on logging accidentally. So it's just one tool, was very noisy, and
Yeah,
what you don't realize is they give you, a reasonable amount of logging for free through their API, but then
yeah,
when you go over, they start charging it, and then if you use something that's really noisy with a
yeah,
lot of output, you can suddenly face a big bill, and so there's all these other extra considerations you need to have in there versus running it on a local system. But I think the advantages grossly outweigh the disadvantages. Because I've had to sit there waiting and waiting and waiting to physically purchase resources, and I know how difficult that is.
yeah, absolutely. I think that's pretty undeniable at this point. And that's the reason, across all industries and fields, you're seeing the adoption of cloud computing, not just bioinformatics. There's nothing unique necessarily in that component of like the advantages of cloud computing in bioinformatics versus other fields. And yeah, those are those things. So those are the considerations of Logging, I feel like data storage catches up with people pretty quickly as well. So understanding things like cold storage and long-term things like that. And I do want to say one thing, just in case, like, there's a cloud architect that hears us talk about, hey, they're all the same, Azure, AWS, or whatever. Like, once you get to the architect level and you're maybe deploying resources for big teams or big application, again, like Terra, the Azure tenant versus a GCP project, that's where some of the discrepancies really come into play. And it's like, oh, GCP is not the same as Azure and is not the same as AWS. But that's more so for the system architect and the person who's administering all these resources, or the application that's administering these resources. For the bioinformatics developer themselves, it's going to look pretty much the same.
Yeah. And it has a great discussion, and I'm sure we could talk all day about this.
As always. All right. So yeah, we'll see everyone in the next one.